Space debris, a growing problem in low Earth orbit. High above us, in the vast expanse of space, lies a critical and growing challenge. It's not an alien invasion or a cosmic catastrophe. It's a human-made problem: space debris. Number 1. The origins of space. Debris space exploration began as a testament to human ingenuity. In 1957, the Soviet Union launched Sputnik, the first artificial satellite into orbit. Since then, thousands of rockets and satellites have followed, propelling humanity into the space age. But with every launch came discarded rocket stages, defunct satellites, and fragments from collisions. These objects became what we now call space debris. Number 2. The scale of the problem. Today, there are over 36,000 tracked objects larger than 10 centimeters in low Earth orbit, and millions of smaller fragments. Even tiny pieces, no bigger than a paint fleck, travel at speeds of up to 28,000 kilometers per hour, fast enough to damage or destroy satellites and spacecraft. The International Space Station, a hub of scientific collaboration, frequently adjusts its orbit to avoid potential collisions. Each maneuver consumes valuable time and resources. Number 3. The Kessler Syndrome. In 1978, NASA scientist Donald Kessler warned of a worst-case scenario: the Kessler Syndrome. In this scenario, collisions between objects in orbit could create a cascade of debris, making parts of space unusable for decades or even centuries. Such an event would jeopardize everything from global communications to weather forecasting and GPS systems, which are integral to modern life. Number 4. Real-life incidents. The dangers of space debris are not hypothetical. In 2009, 2 satellites, Iridium-33 and the defunct Cosmos 2251, collided at a speed of nearly 42,000 kilometers per hour, generating over 2,000 pieces of trackable debris. Such events underscore the urgent need to address this issue. Number 5. Solutions and innovations efforts are underway to tackle the space debris crisis. Proposed solutions range from innovative technologies like robotic arms, harpoons, and nets, to drag sails that help satellites deorbit at the end of their missions. International collaboration is also key. Organizations like the United Nations and the European Space Agency are developing guidelines to mitigate debris, including stricter deorbiting practices and debris avoidance measures. Number 6. The role of responsibility. But technology alone won't solve the problem. The responsibility lies with governments, private companies, and the global community to ensure sustainable practices in space. Every satellite launched must have a plan for safe disposal at the end of its life. Without accountability, the problem will only grow. The skies above us are a shared resource, vital to the future of humanity. By acting now, we can ensure that space remains accessible and safe for generations to come.